In this video, we're going to look at the first step in being able to solve quadratic equations by factoring. Now, a quadratic equation is just something that has an x squared or variable squared in it, and that's the highest exponent. That's all a quadratic is. But let's first look at how we're going to start solve equations like that. So first thing we're going to look at is we're going to look at distribution. Do you remember how to distribute? So in letter A here, to distribute this, to simplify this, we're going to distribute the 2x over both those terms. So we get 2x times 4x, that is 8x squared. And then 2x times negative 3 is negative 6x. And that's it. That's all that problem requires. Now the next problem is a little different because we have what is called a binomial times a binomial, meaning two-term thing, the x and the 5, times a two-term thing, the x and the 2. So what we have to do is we really kind of just ignore the 5 and distribute the x. So we get x times x, which is x squared, and x times 2, which is 2x. Then we ignore the x and distribute the 5. 5 times x, that's 5x, and 5 times 2, that's 10. From here we need to simplify this, so we have an x squared, can't combine that with anything. We have a 2x and a 5x, those together would make a 7x, and then the 10 we can't combine, so we just bring it down. So we get x squared plus 7x plus 10. Now what we're going to be looking at today is we're looking at factoring, which is really just the reverse of this process of distributing, where we take something like this and go back to that, or we take something like this and go back to that. So the first thing we're going to look at is what we call the greatest common factor. So for every factoring problem, you should begin by looking for a GCF, which is in fact that greatest common factor. So let's look at our first examples here, A and B. We want to factor each expression. This means we want to find the number that goes into 2x squared and 8x and divide it out. So 2 and 8, the only number that goes into both of those, or the largest number that does, is 2. And then x squared and x, they both have a single x in them. So now I know what I want to divide out, now I just have to see what's left after I divide it. So 2x squared divided by 2x, that's just x. 8x divided by 2x, that's just 4. And there we go. Now if you were to distribute that 2x back over to that x plus 4, you would get back to that original expression. Let's look at letter B. So in this one, we got 15x squared and 35x. So the largest number that goes into both 15 and 35 is 5. And we have an x squared and an x. So we'll just bring out a single x because that's what both of them have in common. Then if I look, 15x squared divided by 5x, that's going to be 3x. Negative 35x divided by 5x, that's going to be negative 7. That's it. And again, if you were to distribute that 5x over both of those, you get back to this original expression. That's a quick way to kind of check yourself, make sure you're right. Right. So that's the thing you should always look for first. Does it have a greatest common factor? But after that, the problem may take a little bit more work to factor. And so that's when we get into this. And what I like to call this is the sum and product strategy. So if we have a trinomial, meaning a three-term thing, is a quadratic expression, we already know what quadratic means, in standard form, meaning ax squared plus bx plus c, it's in that form, and the a value is 1. So this a value, instead of being an a, is really just a 1, or there's no number there at all because you don't necessarily have to write the 1. We're going to find two factors of the c term, so this last number, which have the sum equal to the b term, meaning what can I multiply to get c that'll also add to get b. Then we're going to write a quadratic as the product of the two binomial factors, x plus p and x plus q. Now the p and the q are what multiply to give us c and add to give us b. So let's take a look at an example of this. So we have x squared plus 7x plus 12. So what I like to do is I make a little table. I have a sum and a product. So I make a little table here. What can I multiply, or what can I sum to get 7 and multiply to get 12? So it's easier to think about the multiples of 12 than it is the sum of 7, because literally any two numbers could add up to give you 7. You just need to pick two random numbers that'll do that. But to get multiply to get 12, there's a lot less options. So one option is 1 times 12, but if I add 1 plus 12, it's going to be 13. So that won't work. It won't give me 7. So another way to get 12 is 2 and 6. 6 plus 2, though, is 8. We're getting closer, but not exactly there yet. Another factor pair of 12 is 3 times 4. And then 4 plus 3 is 7, so that one works. So those are my p and q values. So I just write x plus p, which is 3, and x plus 4, which is q. Now, it wouldn't matter the order I write these in, if it's x plus 3, x plus 4, or x plus 4, then x plus 3. Because when you multiply things, the order doesn't matter. Now, if you're wondering, well, how does this equal that? Well, remember back from the original multiplying distribution there, if we were to multiply this back out, we would get x times x, which is x squared, x times 4, which is 4x, and then 3 times x, 3x, 3 times 4, which is 12. And then we combine the 3x and the 4x, and we get x squared plus 7x plus 12, which, hey, is the same as that. Now, you don't have to do this check every time, but it would be a good practice to make sure that you're getting the answer right until you get really good at this. So I'm going to just erase this so you don't think you have to do it every time as actual part of the problem. This is our final answer. All right, let's look at the next one. So again, we always want to find the product of the last number, the sum of the b term. So here we go. We want a sum and a product. We want a sum of negative 10 and a product of 25. So if I need to multiply to get a positive number and add to get a negative number, what that means is both these numbers have to be negative. So think about, what can I multiply to get 25? The first thing that I think of is 5 and 5. But the problem with that is that's going to give me a positive 10, and I want a negative 10. But what if I make both of those negative? If I have a negative 5 and a negative 5, that will multiply to give me 25, and it'll add to give me negative 10. And so there we go. So that is our solution, x minus 5 and x minus 5. Now what's cool about this one, because it repeats, we can actually write this as x minus 5 squared, which would be the same as that expression there. Okay, let's look at letter C. So in C, you may notice something about all three of those numbers, 2, 4, and 70. They are all even numbers, meaning that 2 will go into all of them. So what we have here is a greatest common factor. Now you have to notice, though, that we have an x squared and x, and no x's with the 70 here. So we can't factor out an x because there isn't an x to take out. So the greatest common factor is just 2, and then we write down what's left if we divide out that 2. The x squared plus 2x minus 35. Now what we're going to do is, once we've taken out that greatest common factor, now we're going to do our sum and our product on the numbers inside the parentheses here. So I'm going to see, what can I add to get 2, multiply to get negative 35. So think about the numbers that just multiply to give you positive 35. The only things, the ones that pop in my mind instantly are 5 and 7. Positive 5 and positive 7 gives me positive 35, and I want negative 35, so one of them needs to be negative. But since I want to add to be a positive 2, the smaller number should be negative, so when I add 7 plus negative 5, I get positive 2. So then this x squared plus 2x minus 35 becomes x minus 5 times x plus 7. Then all I need to do is bring down that 2. And that is the final answer there. Now if you multiplied all this back out, you would get back to this original expression. Alright, one last one to look at here. We have 5x squared minus 20x minus 225. So if you notice, all of these have a 5 in them. So we're going to factor out that 5. And then we'll see what's left once that's divided out. So we get x squared, 20 divided by 4, or 5 is 4x, and then 225 divided by 5 is 45. And just bring down whatever sign was already there. Now we're going to factor what's in the parentheses here using our sum and product method. Let's make a little table here. We got a sum and a product. We want a sum of -4 and a product of -45. So there's a bunch of things that make 45. One thing is 1 and 45, but there's no way to combine those either subtracting or adding to get that -4. And what I like to think about, since I want the answer to be negative, that means the larger number would have to be negative. That's -44. Not going to work. Another thing that goes into 45 is 3 and -15. But those make -12, not -4, so that won't work. 4 doesn't go into 45, but 5 does. And 5 times 9 makes 45. And since I want a negative, I'll make it -9. So -9 times 5, or plus 5 is -4. So there we go. That's the one that will work. Now from here, all we have to do is write that down. So bring down that 5. And then this x squared minus 4x minus 45 becomes x plus 5 times x minus 9. And that is our solution. We printed the whole packet. All of the notes are in the front of the packet, and all the practice work starts on page 9. So this is the page we want you guys to start practicing on. Notice this first part is just finding the greatest common factor, no sum and product. And the second one is sum and product, and there may be some greatest common factor in the initial part of the problem. Okay, but that's the page we want you guys to practice today.